Hello everyone, this is Disha Sunil, and in this video we will be covering two questions of data science assignment. The first question is explain the difference between supervised and unsupervised learning, provide example of algorithm for each type of learning and discuss scenario where each would be appropriately used. The answer is the key difference is the use of a label data. Supervised learning uses label input output pair to train a model to predict outcomes while unsupervised learning uses unlabeled data to find hidden patterns and structure without specific guidance. The supervised learning involves training a model on a dataset that includes both input features and corresponding output labels. The algorithm learns a mapping functions from the input to the output based on this example. The example of the algorithm are linear regression and classification. Linear regressions used to predict a continuous value such as house price based on features like location and number of rooms. Classification used to predict a category or class such as identifying if a image contains a lion or a bird. The appropriate scenarios are spam detection and the price prediction. The spam detection trains a model on a data set of labeled data, email labeled as spam or non spam, to automatically filter a new email. Price prediction is the predicting the future price of cryptocurrency based on the historical market data and other relevant features. Now, the unsupervised learning involves the training a model on unlabeled data, where the goal is to explore the data and find inherent structure, pattern, or grouping within it without prior knowledge of output label. The example of the algorithm are clustering and association. The clustering is the grouping similar data points together, such as k-mean clustering, where association is finding rules that describe large portions of data, such as market basket analysis. The appropriate scenarios are first, the customer segmentation, and the second is anomalies detection. The customer the customer segmentation grouping customer into different segments based on their purchasing behavior to tailor market strategies. The anomaly detection is identifying unusual patterns in network traffic that might indicate a security threat. Now, the second question is describe the concept of hypothesis space in machine learning. Explain the algorithm find S. Find a hypothesis by find S from the following instance in the training set. This is a training set, origin, manufacturer, color, decades, type, and class. The hypothesis space and find S. In machine learning, the hypothesis space S is the set of all possible hypotheses that a learning algorithm considers. The goal of a learning process is to find a hypothesis within the space that best fit the training data. The find S algorithm is a simple concept learning algorithm that find the most specific hypothesis in the hypothesis space that is consistent with all the positive training example. It starts with the most specific possible hypothesis at zero and then generalizes this hypothesis only when it encounters a positive example that is not covered by the current hypothesis. Negative examples are ignored, which a key limitation of this algorithm. Finding a hypothesis by find S. First step is initializing the hypothesis. The initial hypothesis H0 is the most specific possible hypothesis, which specifies that all attributes must match the current value, often represented by the first positive example or by the phi, the empty set of all attribute. Using the first positive example as a starting point, H0 equals to Japan, Honda, Blue, 1980 economy. The step 2 process the second example. The second example is negative, so the hypothesis H0 remain unchanged. The step 3 process the third example. The third example is positive, hence we have to change the hypothesis. Japan, Tokyo, Blue, 1990 economy, comparing it with H0. The origin Japan it matches, the manufacturer Honda versus Toyota it mismatches, hence the right arrow and generalize it to question mark. The class is blue which is match and the decade 1980 versus 1990 which is mismatch, hence right arrow and generalize to question mark. Type economy it also matches. The new hypothesis H1 is generalized to H1 equals to Japan question mark blue question mark economy. Step 4 process the fourth Step 4 process the fourth example. The fourth example is negative, so the hypothesis H1 remain unchanged. Step 5 process the fifth example. The fifth example is positive. Honda, Japan, Honda, white, 1980 economy comparing with H1. Japan, which matches Honda versus question mark, matches H question mark cover all the values. Color white versus blue, it mismatches, hence right arrow and generalized to question mark. Decades 1980 versus question mark, which is matches because It covers all the values. Type economy, which also matches. The new hypothesis H2 is generalized to H2 equals to Japan, question mark, question mark, question mark, economy. Therefore, this is the final hypothesis.